Lesson on rates, and obviously this is video A for the first lesson in Unit 2 for 7th grade. And before we dive into the math, let's just quickly reference what does a rate mean? What is a rate? So a rate can be thought of as an action taken over a certain period of time. So here's an example. Johnny eats 5 cookies per minute. Well, Johnny eating 5 cookies is our action. So this is like our action part. And then the per minute part is our time. So something was done over a certain amount of time. So you've got an action over a certain amount of time making this a rate. And it can be written in fraction form. So 5 cookies eaten every minute can be written as a fraction, 5 cookies per 1 minute. And so this part right here might be how you would express or write a rate. Many of you are familiar with miles per hour. And in fact, this abbreviation can be written in fraction form, miles per hour. So, for example, if you're going 5 miles per hour, you're going pretty slow because you're only going to go a total of 5 miles for every hour of like fast walking or slow jogging. And so that's what a rate is. But it's not all about like speed in the sense of, you're walking, hiking, biking. It can be any action. It could be eating cookies. Okay. Here's our first example. There's only going to be 2. Sally bikes 2 miles every 1/3 hour. How far will she bike in 1 hour? How far in 2 hours? How far in 4 hours? One of the easiest ways for me to solve problems like this is to use a table. So 2 miles every 1/3 hour. So I do a table that expresses distance over time. Because remember, a rate is an action over time. So she's biking a distance. So that's why I'm putting distance in the top, because that's her action. She's moving a certain distance. And then time obviously goes in the bottom. So after 1/3 hour, she went 2 miles. After 2/3, she's going to have moved a total of 4 miles because 2 miles for this 1/3 and 2 miles for this 1/3 total to make 4. So notice I'm writing the total number in the table. And then 1/3 plus a third is 2/3 plus another third gets us 1. So at time 1 hour, we've gone 6 miles. So now we've answered one part of the question, which is how far did she go in 1 hour? She went 6 miles. And this table really helps me visualize this. And so I'll just use this table to finish this off. Same idea. We figured out that there's 4 miles over the 2/3 and 6 miles over the 1. But notice the table here, I kind of jumped from 1 to 2. And instead of going, putting a 1 here and then making this 1 and a third and making this next one 1 and 2/3, I took a shortcut. And this is why I took a shortcut with my table. Because I know that if she went 6 miles in 1 hour, then if you times the time by 2, if you double the time from 1 to 2, then you also have to double the distance. So if she can go 6 miles every 1 hour, then in 2 hours she's going to have gone 12 miles. And then similarly again, if she can go 12 miles in 2 hours, then in 4 hours she'll have gone 24 miles. So we can kind of take some shortcuts here to answer our question. Once we figure out how far she would have biked in 1 hour, it goes a lot faster for us. So I'm going to quickly recap this problem and move on to the next. It said she went 1/3 mile. Oh, I'm sorry. I wrote this wrong. My bad. And said it wrong. It said she went 2 miles every 1/3 hour. This is kind of a weird rate because there's a fraction in the denominator. And so one strategy we can use is fill out a table like this and list our time in increments of 1/3 until we get to the whole, So 1/3, 2/3, and then obviously 3/3 is our 1. Because you could think of this as 3 over 3 or 1. And so then we just kind of fill in the top and to answer our question. I want to do one more example with you though to make this even clearer. Let's see. So here's our example. It says Jeff hikes 1/2 mile every 1/4 hour. Lisa hikes 1/3 mile every 1/6 hour. how far do they each hike in 1 hour, 2 hours? So look at this. Jeff's rate is 1/2 mile every 1/4 hour. Lisa's rate is 1/3 mile every 1/6 hour. Again, these are kind of weird rates. Like it's not 1 mile per hour, it's not 5 miles per hour, it's a 1/2 mile every 1/4 hour. That's kind of weird. So one way to figure this stuff out is to use a table. So let's use a table for Jeff first. Remember, Jeff was 1/2 mile for every 1/4 hour. So I kind of did the same thing with my table. I set it up with a quarter, increments of a quarter in the bottom or in the denominator spot up until I got to a whole, and then I just kind of skipped to 2. So if he did 1/2 and a quarter, the second 1/4 hour is going to be another 1/2, and a 1/2 plus a 1/2 is 1. Okay? And then another quarter gets us to 3/4 hours, and then another 1/2 gets us to 1 1/2. So notice what I'm doing. In the top part here, I'm adding a 1/2 because it's a 1/2 up here. And in the denominator, I'm adding a quarter each time. And then, of course, 3/4 plus a quarter is 4/4, which is 1. And so 1 1/2 plus a 1/2 is 2. So now I know that in 1 hour, Jeff went 2 miles. So then it's really easy for me to figure out how far he would have gone in 2 hours, because I just double it, and that would be 4 miles. Okay, so I have this information for Jeff. Now remember, it asked us as well for Lisa, 1/3 miles for every 1/6 hour. So let's fill out a table for Lisa. So down here I have increments of 6ths up until I get to 1. And then I have to count by thirds now, because every 6th hour we go up by a third. So a third plus a third is 2/3. 2/3 plus a third is 3/3, or 1. And 1 1/3, 1 2/3, and then finally 2. So this is interesting. This 1 here is like an or. 3/3 or 1. They mean the same thing. So in the first 1/6 of the hour, we did a 1/3 of a mile, because that's the rate they gave us. In the second 1/6 of the hour, we had gone a total of 2/3 miles, and so on and so forth. So for Lisa, I know in 1 hour, and I know that because of this part right here, because I counted up to 1, she went 2 miles. And it also asked how far she went in 2 hours. So I know for 2 hours, I just have to double this. She went 4 miles. Interestingly, that's the same thing we got for Jeff. And that's an interesting, what should I say, coincidence, I guess, that these rates would simplify to kind of be the same thing. A 1/2 compares to a 1/4 the same way a 1/3 compares to a 1/6. And that makes sense. A quarter is 1/2 of a 1/2, and a 1/6 is 1/2 of a 1/3. So even though these rates look different, they simplify down to equal the exact same amount of distance over the exact same amount of time. So that was kind of weird. But anyways, when you get weird rates like this, fill in these tables to help you get to the answers. And that's what your worksheet's going to ask you to do, is to fill in these tables. I hope this video was helpful for you. Let me sit here again. I hope this video is helpful. And if you're struggling with this, focus on these 2 things. First, make sure that the denominator, or the bottom portion of your table, matches the bottom portion of your rate. And make sure the numerator spot, or the top part in your table, matches the increments in the top part of your rate, or it matches the distance, and the time matches the time. Thank you. Good luck.